In this lesson, we're going to look at solving equations with rational exponents. And rational exponents are like x to the 2/3 or the quantity x minus 3 to the 1/4. So my goal is still to find the value of x that makes that equation true, because we are solving. So I have to look at the fact that in this first one, x to the 2/3 equals 64, what value of x is going to work? Well, what does x to the 2/3 mean? If you remember our rules of exponents, this would be the same thing as the cubed root of x squared. So if I look at that, I can basically have the cubed root of x, and then I have that whole thing squared. How could I get rid of the squaring? I could take the square root to undo the squaring, and I get the cubed root of x equals the square root of 64. And so here I have, technically this should be plus minus, because I am taking the square root, just like the square root property, and I have the cubed root of x equals plus or minus 8. And then, how do I get rid of cubed root? I get rid of the cubed root by taking both sides cubed. And so what I end up getting here is x equals, I have plus or minus 8 all cubed. So I actually have two different answers here. I have plus or minus 512. Now, the plus minus part is the part that a lot of people forget here. And what I always like to do in a problem like this is think, okay, well, if I just did the positive square root of 64 and came up with 8, try the negative in my actual equation. If the negative works, then it's also a solution. And negative 512 does actually work. If I take the cubed root of that and then square it, I'm going to get a positive 64. I won't get a negative 64. In this next example, I have a quantity x minus 3 to the 1/4 equals 5. So in this case, I can write it if I want to as the fourth root of x minus 3, or I can just look at it as knowing it's a fourth root, and I'm going to take both sides to the fourth power. Okay, so here I'm going to end up with x minus 3 equals 5 to the fourth power is 625. And then I just add 3 to both sides, and I get x equals 628. Okay, and I can go back and I can check this answer, and I didn't check the last one, but I probably should. 628 minus 3 to the 1/4 equals 5. And you can actually check this right on your calculator, put it into your calculator. Let's go back and look at this first one. If I take 512 to the 2/3 on my calculator, you'll see that I get 64. If I take negative 512 to the 2/3 on my calculator, I'll also get 64. This last example you could see is a little bit more challenging, because what I'm dealing with is an x to the 2/3 and an x to the 1/3. So I can't combine those. They don't have the same exponent. They're not like terms. And then I also have this constant right here. But if you look at this problem and you take off like this divided by 3 here and the divided by 3 here, it looks like a quadratic equation. So we call this like quadratic in form. It's not technically a quadratic equation, but it looks very similar to a quadratic equation. So I'm going to treat this kind of like a quadratic equation and solve by factoring. Now, if you had x squared plus 3x minus 10 equals 0, how would I solve this? Well, this is factorable. What multiplies to give me negative 10 and adds to give me 3. And my answer would be negative 5 and negative 2, so I have x plus 5, x minus 2. So I'm going to do the same thing here, except that I don't have just x and x, because it's not going to give me x squared. I need x to the 2/3. So what I'm going to have here is x to the 1/3 and x to the 1/3, because the product of x to the 1/3 times x to the 1/3 is going to be x to the 2/3. And x to the 1/3 is what I have as my power in the middle. So my hint here is usually I look at what's in the middle here. That's generally what's going to go here and here. Just make sure when I multiply those, I get what I have here. Okay, so I still use the same plus 5 minus 2. So what I'm going to have is x to the 1/3 plus 5 equals 0. X to the 1/3 minus 2 equals 0. So I get x to the 1/3 equals negative 5, x to the 1/3 equals 2. So remember that this is very similar to having the cubed root of x equals negative 5. So to undo the cubed root, I need to take and cube both sides. And so I get x equals negative 125. And here I'm going to do the same thing. I'm not going to show the cubed root. I'll just do that. And I get x equals 8. And in order to go back and check this one, it's a little bit harder, but I can take, let's do the negative 125 to the 2/3. And on your calculator, make sure you put parentheses there. To the 2/3, or 1/3, sorry. And then minus 10, and you should get 0. Okay, just a couple things to recap here. With your rational exponents, you need to be careful, check your answers, make sure, if you can have a negative, you put the negative as a solution as well. The other thing to really watch out for is right here where I had x to the 1/3. It's very common for people to take the cubed root instead of cubing. So if it helps you to write it in this form, because it's x to the 1/3, not x to the 3rd, write it in this form, and then it's pretty obvious that you're supposed to cube both sides. But my biggest suggestion on all of these is to actually go through the process of checking. Checking on your calculator is actually quite quick and easy, and you can guarantee that you've got the right solutions.